Good morning to all. I am Jamuna. I am working as a assistant professor in the Department of Artificial Intelligence and Data Science in Erode Sengundar Engineering College. Today we are going to discuss about fundamentals of operating system. That means operating system subject. In that, what is the introduction to an operating system? What are the basic concepts in operating systems? That one we are going to discuss today. And these are the topics we are going to cover: what operating system will do, and computer system organization, computer system architecture, and operating system structure, and operating system operations, some of the managements: process management, memory management, storage management, and production and security, kernel data structure, and computing environment, and open source operating systems. And first of all, we want to see what is an objective for this operating system. This operating system, it is a basic organization of computer system. Without that operating system, we cannot use the computer systems. And it provide a grand tour of the major components of operating systems. And to give an overview of a many type of computing environment, there are so many environment are there. We are going to see some overview of that, and to explore several of open source operating systems. What is meant by open source operating system means what are the free operating systems nowadays we are using. That one we are going to see that, and we will see now definition. What is an operating system? It is one of the program. That means it is a software. Software means set of programs. So operating system is a program that acts as an intermediary between a user of a computer and the computer hardware. That means this operating system interconnects both the user and the computer hardware. It acts as a intermediary between the user and the computer hardware. The operating system goals: it executes user programs and makes solving user problems very easily. So just imagine, now we are using the computers without operating system means it is, we cannot use the computer system. We can't do any programs. We cannot do, nothing is there. So it execute the user programs and make solving the user problems very easier. There's so many problems are there. For example, just a simple calculator, and also so many applications are there for making cutting the songs and song maker. And in Word we are using so many things that are solved by using a Word application and Excel. These are the applications. It makes solving user problems very easier. It make the computer system very convenient to use, and use the computer hardware in an efficient manner. These are the operating system goals. And computer system structure, we know that computer system has been divided into 4 components. It is a very important thing in operating system. There are 4 components in computer system. What and all that means: hardware, operating system, application programs, and users. We know that hardware means it is just a computing resources. For example, CPU, memory, input output devices, and keyboard. These are the hardwares. Operating system means it is a software. It is a program that acts as an interface between user and the hardware, and it controls and coordinates the use of the hardware among various applications and users. That means it, by using the user problems, it is everything solved by using this operating system. It controls and coordinates the hardware. And application programs, application program means these are the programs that are run in the computer. For example, word processors, Excel, and video games, web browsers, compilers, and database systems. These are the application programs. Define the ways in which the system resources are used to solve the computing problems of the users. It is going to solve the computing problems of the user. For example, we want to do some calculations, means we need Excel. Okay, that is one of the application program. Then calculator, the calculator is one of the application program. By using the application program only, users can solve their problems. And fourth component is users. We are the users. People, machines and other computers are the users. And these are the structure of computer system. See that the computer hardware is there, an operating system, and system and application programs are there, and they are connected with the users. There are so many users, they are communicating with the operating system by means of some application programs, system and application programs. What is meant by system programs and application programs? System program means that are the default programs that are already inbuilt in computers. For example, compilers, assemblers, interpreters. These are the system programs. An application program means that user can install some application and we are using that application to solve a problem. That is application programs. An operating system, we know that it acts as an interface between user and the hardware and computer hardware. It is a structure of a computer system. And next topic, what is a definition? We already know the definition. And one more definition we are going to see, that operating system is used as a resource allocator, and also operating system is a control program. We already saw that what is a control program. It's that operating system controls everything what is happening inside the computer, what is happening in hardware. Everything will be controlled by operating system. It controls execution of programs to prevent errors and improper use of the computer. And resource allocate means the operating system allocates and manages the all resources. See, it decides between conflicting requests for efficient and fair resource use. The operating system allocates all the resources and manages all the resources. So the operating system is called as a resource allocator and a control program. And this definition, this continuation, is no universally accepted definition. We know that we are telling no, it acts as a interface between user and the hardware. It is not a universally accepted definition. So just we are selling everything a vendor ships when we order an operating system. It is a good approximation. But now, but humans define some definition to a operating system. Okay, in operating system, one important term we are going to see, what is that? Kernel. The one program running at all times on the computer is a kernel. Operating system, it is act as an interface between user and the hardware, and inside that one important core of the operating system is called as kernel. It is a part of OS which handles all the details of sharing resources and device handling, that provides basic services for all other parts of the OS. So it is a core of OS. It handles the communication between hardware and the software. So it is a one of the part of operating system. Either that we know that the system program and application program. Already we know that system program is already inbuilt program. Application program is the users installed some applications to solve their problems. It is an application program. Computer setup. Bootstrap program. What is meant by bootstrap program? Means is loaded at power up or reboot. When we are switch on the computer, we are telling now system is booting on, or power up or reboot. That function, that program is known as bootstrap program. And the bootstrap program is typically stored in a ROM or EPROM, generally known as firmware. That already stored program is known as firmware. That action, what we are going to do, that action, that means the booting up, the power up, that or reboot, that process is known as bootstrap program. That bootstrap, when we are switch on the system, we are booting the system, it initialize all aspects of system and loads operating system kernel and starts execution. The operating system first loads the kernel and it starts the execution. An operating system organization, it is an operating system organization. See here, one or more CPUs, device controllers connect through common bus providing access to shared memory. It is everything connect in a common bus. It providing access to the shared memory, it sharing their memory. That means concurrent execution of CPUs and devices competing for memory cycles. Concurrent execution means parallel execution. Now we are taking some example. Now we are working in a computer. What we are doing means we are chatting something in our mail, Gmail, and we are listening some songs. That means media player is running, and at the same time we are working in word processor. Like that, multiple process concurrent execution is happening in the CPU. Then computer system operation. Here input output devices and the CPU can execute concurrently. That means all the input output devices and CPU can execute concurrently. That means they are working parallelly. Each device controller is in charge of a particular device type, and also each device controller has a local buffer. What is meant by buffer? Buffer means we know that it is a temporary storage. Whatever we are doing, what and all we are executing some process, all the process will be stored in a buffer memory. That means it is a temporary storage device. CPU moves data from or to main memory to or from local buffer. That means CPU moves all the data, all the process details and everything to or from the main memory or to or from the local buffer. That means CPU moves the data from main memory to local buffers. Input output is from the device to local buffer of controller. First, CPU moves the data from main memory to a local buffer and that buffer to that control of the device. And device controller informs CPU that it has finished its operation by causing an interrupt. Here we are going to see one new concept. What is an interrupt? Interrupt means it is a signal. For example, now we are downloading some things. We are going to give some download option. After finish the downloading, here some message will come. Your data is downloaded, like that. So that message is known as interrupt. Now in our term we are telling that is a message, but in computer it takes as a signals. After completion of all the operation, it causing an interrupt. That means it causing some signals to the CPU to inform that operation is completed. And some functions of interrupts are there. That interrupt transfers control to the interrupt service routine, generally through the interrupt vector. What is an interrupt vector? Means which contains the address of the all service routines. Now that CPU sends some signal, that means send some interrupt to some process. That process is completed, like that the operation is completed, like that. That interrupt vector, in interrupt it is having some interrupt vector. What it is contains? It contains the address of all the service routines. That interrupt architecture must save the address of the interrupted instruction. Here a trap or execution is a software generated interrupt that caused either by an error or a user request. Here interrupt, there are two types of interrupt are there. That means hardware interrupt and software interrupt. Hardware interrupt that are caused by hardware resources, and software generated interrupt is known as a trap or exception. This exception is known as error. Trap or exception is known as error. For example, how the software it will generate some interrupt, that means for example something divided by 0 or some syntax errors. These are the interrupts that is caused by the software. Operating system always interrupt driven. What is it by interrupt driven? See, nowadays we are performing multiple number of tasks, multiple number of process. So operating system we are using on better operating system means it always completes its operation, and it will surely sends some interrupt to a CPU. So all the process after the completion of its operation, it sends some interrupt to the CPU. So operating system is a interrupt driven. The operating system preserves the state of the CPU by storing registers and the program counter. It stores some registers. It is used for some storing the data, storing purpose, and program counter means that program counter having the address of the next instruction to be executed. This program counter contains the address of the next instruction to be executed and determines which type of interrupt has occurred. That means first, polling. Polling means it is a process in which the CPU constantly checks the status of the device. Polling means it's constantly the CPU checks the status of the device. And vectored interrupt system. Vectored means it is having some numbers in the interrupt signal. So it is known as vectored interrupt system. It is an interrupt timeline. Now listen, here CPU and input output device is there. Here input output request and transfer done, and again another next interrupt will come. No, that input output request and transfer done. For CPU, what are the operations are done by CPU? User process executing and input output interrupt processing. An input output device, it will idle for some time and it will transfer something. See here, first we will see about input output request. In input output request, the input output device is idle in stage, and after that it is starting transferring up to the transfer done. It will reach the transfer done timeline, and then again it will wait for the next input output request, so it will be idle for some time, and again it starts transferring and up to it transfer the data up to the timeline transfer done, and again it will wait for next input output request. Here the simple concept, when the interrupt will start is in the user process executing is continuing up to the transfer is completed. After the transfer completed, the CPU send some input output interrupt processing, and again it continuing user process executing up to next process will complete its transformation. So up to that it continuing user process executing. After transfer done, again it will cause some interrupt. So this is a timeline for interrupt. And now we are going to see some storage definitions and notation review. We know that already the basic unit of computer storage is bit. A bit can contain one or two more values, zeros and ones, and all other storage in a computer is based on collection of bits. Given enough bits, it is amazing how many things a computer can represent. You know that in bits we are representing numbers, letters, images, movies, sounds, documents and programs, and so on. A byte is a 8 bit, and on most computers it is the smallest convenient chunk of storage. For example, most computers don't have an instruction to move a bit, but do have one to move a byte. A less common term is word. First one bit, and then a collection of 8 bits is known as byte, and then word, which is given a computer architecture's native unit of data. That means a word is made up of one or more bytes. For example, a computer that has 64-bit registers and 64-bit memory addressing typically has 64-bit, that means 8-byte words. A computer executes many operations in its native word size rather than a byte at a time. See, 8-bit is known as 1 byte, 8 byte is known as 1 word. Computer storage, along with most computer throughput, is generally measured and manipulated in bytes and collection of bytes. We know that a kilobyte is 1024 bytes, a megabyte is 1024 power 2 bytes, a gigabyte is 1024 power 3 bytes, a terabyte is 1024 power 4 bytes, petabyte is 1024 power 5 bytes. Computer manufacturers often round off these numbers and say that a megabyte is 1 million byte and a gigabyte is 1 billion byte. Networking measurements are an exception to this general rule. They are given in byte because network move data a byte at a time, a bit at a time, not a byte. So always in a general rule, the networks move the data a bit at a time. And storage structure, these are the storage devices we are used in a computer: main memory, secondary storage, and hard disk, and solid state disk. What is a main memory? We know that it is a very large storage media that the CPU can access directly. That means random access memory. It is a typically volatile memory. What is an volatile? Volatile is a type of storage whose contents are erased when the system's power is turned off or interrupted. When we switch off the system, all the contents are erased. That is volatile. And secondary storage, it is an extension of main memory that provides large non-volatile storage capacity. So non-volatile means it is also one computer memory that can retain the storage information even after the power is removed, even after the system has switched off or power is off, then also the content will retain its storage. That means non-volatile. Next one, hard disk. You know that hard disk, it is a metal or glass platters covered with a magnetic recording material. The disk surface is logically divided into tracks which are subdivided into sectors. The disk controller determines the logical interaction between the device and the computer. The hard disk means it comes under CD, DVD, these are under hard disk. And solid state disk, it is faster than hard disk. It is also non-volatile. There are various technologies are there, but compared to hard disk and secondary storage, the solid state disk are more popular. For example, motherboard. And storage hierarchy. Storage system organized in hierarchy based on speed, cost, and volatility. And one more topic we are going to say, what is an cache memory. In mobile phones nowadays, maximum 1 week or within 1 month we want to clear this cache memory. That means, what is that cache memory means? It is a copy of the information. It is stored in a cache memory. Whatever we are doing the process, the cache memory stores one copy of the information. And what is meant by device drivers? Device drivers for each device control to manage input output. It provides uniform interface between controller and kernel. For example, Now we are connecting one printer to the computer system. Now just a connection is enough for taking printout from the printer? No, we need some device drivers. That means printer drivers we need to take the printout. So that drivers is known as device drivers. This is a storage device hierarchy. Last one, magnetic tape. This magnetic tape is nowadays maximum we are using for the storage purpose. And then optical disk, and then hard disk, solid state disk, then main memory, cache memory, and registers. These are the storage device hierarchy. Direct memory access structure. The name itself, we know that direct memory access. In some high speed input output devices, they can able to transmit information at close to memory speed. That means it can share the information directly to the memory. So device controller transfers blocks of data from buffer storage directly to main memory without CPU intervention. Only one interrupt is generated per block rather than one interrupt per byte. Here, from buffer storage to main memory, the device controller transfers the blocks of data. That means directly it accesses the memory without any CPU intervention. See the diagram. It is a CPU and this is a device and this is memory. And CPU, there are threads of execution. There are so many flow of execution is there. Here to the CPU, to the buffer memory, input output request and data and interrupts are passing, and without interrupting that CPU, that buffer memory directly acts as the main memory. Computer system architecture. See, most systems use a single general purpose processor. Single general processor means single process. Most systems we are using is single processor systems, and multi-processing systems are there. That means multiple processors, they are parallelly working in a single computer. It is also known as parallel systems and tightly coupled systems. Advantages are it increase the throughput and economy of scale and increase the reliability. That means graceful degradation or fault tolerance. There are two types are there: asymmetric multiprocessing and symmetric multiprocessing. Asymmetric means each processor is assigned a specific task, and symmetric multiprocessing means each processor performs all tasks. See this diagram for symmetric multiprocessing. It is architecture. See, what is a symmetric multiprocessing? We know that each processor performs all tasks. See here, that CPU performs all the tasks that is connected to the memory. And then cluster system. Here multi-processing means multiple processors working together. Here cluster system means multiple systems working together. They are usually sharing the storage via storage area network. That means SAN. It provides the high availability services which survive failures. These are here also two types of clustering are there: asymmetric clustering, symmetric clustering. What is meant by asymmetric clustering means it has one machine in hot standby mode. Only one machine will be there. And symmetric clustering means multiple nodes running applications monitoring each other. Multiple nodes are running together. And some clusters are for high performance computer. Here multiple systems are connected and working together means it provide high performance. And it is an architecture for clustering system. See, multiple computers are interconnected by using a storage area network, SAN. Next topic we are going to see about what is an multi-programming. Here multi-programming means it is a technique to execute number of programs simultaneously by a single processor. Single processors, it execute number of programs, multiple programs simultaneously. In multiple programming, number of processors reside in a main memory at a time. The OS picks and begins to execute one of the jobs in the main memory. if any input output wait happen in the process, then CPU switch from that job to another job, and CPU is not idle at any stage. So it won't wait, CPU won't wait for any jobs. It picks some other jobs from the ready queue and it will start processing. See here, it is an architecture, it is operating system, there are so many jobs are there, and it is one more architecture. See here, it is a secondary storage and CPU is there. There are job A to job F is there. It is a main memory. Job A is doing input output operation in secondary storage, and CPU is performing job B is in execution, that is job B is in CPU, and another job C, D, E and F are waiting for CPU. It is a multi-programming operating system architecture. And multitasking, what is multitasking? First we are going to see single tasking, operating system that allow only one user to run one program at a time. It is known as single user or single tasking operating system. For example, one user is performing only one task. One user just working in a Microsoft Word, that is only one task performed by one user. It is known as single tasking operating system. And most current operating system and computers have moved beyond this stage to multitasking. What is meant by multitasking? The operating system allows more than one task or program to be executed at a time. That means one user performs multiple tasks at the same time. One user listening the song and performing some work in Microsoft Word and also doing some downloading. It is a one user performing multiple tasks. This multitasking has similar approach and meaning to that of multi-programming, in that they both refer to the efficient utilization of a CPU by two or more programs. The both also multi-programming and multitasking also, it increase the efficient utilization of the CPU. It is an architecture of multitasking. See, the CPU is there, operating system is there. One user performing multiple tasks, Word and web browser and email. And it is a comparison between multi-programming and multitasking. What is a multi-programming? We know that it is a multi-user system. The systems that are used by many users at a time. But multitasking means it is a single user system. The systems that are used only by one user at a time. And multi-programming, it refers to a concurrent execution of multiple jobs that may be same user or different user. Concurrent means simultaneous or parallel execution. And in multitasking, it refers to concurrent execution of multiple jobs by same user. Multitasking means the only difference between multi-program multitasking means multi-programming is performed by multiple users and multitasking is performed by single user. And these are the types of operating system: batch operating system, multi-programming operating system, time sharing operating system and real-time system. Batch operating system means it is an operating system which analyzes our inputs and groups them into a batches. This batch operating system could only execute one program at a time as a batch. For example, nowadays we are using payroll and statistical analysis. These are the batch operating system. And multi-program, we already know that several programs that run at the same time. And time sharing operating system means while doing multi-programming and multitasking, we are sharing our computer resources among many users. So this operating system is time sharing operating system. Real-time operating system means with a specified time, we already specified some time. In the time, that process, it must process the information and produce the response. With a specified information, it processes the information and produce the response. It is a batch operating system. See that there are so many jobs are there. That operating system batches the jobs. That means groups the jobs into batches and it performed by CPU. Only one batch will be alerted to the CPU at the same time. One process will be executed in one time. and time sharing. See here, multiple users sharing the CPU is known as time sharing. What is a virtual memory? Virtual memory is a part of a system's secondary storage memory, but it acts as a part of a main memory. That means virtual memory allows a system to execute a heavier application or multiple applications simultaneously without exhausting the RAM. It means random access memory can behave as if its total RAM resources were equal to the whole amount of physical RAM plus the complete amount of virtual RAM. That means the total RAM is equal to the physical RAM and also the complete amount of virtual RAM. See, this is a virtual memory. It is a memory map. This is a physical memory. Here it is a RAM. This RAM is equal to the total amount of physical memory and also the virtual memory. The process management. First we know that what is an process. Process is a program in execution. It is a unit of work within the system. Program is a passive entity. Process is a active entity. Because by using the program only we are doing some execution, so it will become process. So the program is a passive entity, process is an active entity. The process needs some resources to accomplish its task. What are the resources? Means CPU, memory, input output files for initializing the data. And process termination, it requires reclaim of all reusable resources. And there are two types of processes: single threaded process and multi-threaded process. Single threaded process means at a one time only one process will be performed. It has one program counter. We already see this concept, program counter, that specifying the location of next instruction to be executed. The program executes instructions sequentially at a time, one at a time, until completion. That means the process is executes the instructions one at a time. And multi-threaded process has one program counter per thread. Multi-threaded process, it has one program counter per thread. What is a thread? We already saw that it is a flow of execution. Okay, and per thread it has one program counter. Typically system has many process, some user, some operating system running concurrently on one or more CPUs concurrently by multiplexing the CPUs among the process and threads. See, single threaded process means the process executes the instructions one at a time. Multi-threaded process means it executes the instructions simultaneously. And we saw that already. Program is a passive entity and process is a active entity. It is an executable file containing a list of instructions stored on a disk. Process is a with the program counter. It's specifying that next instruction to execute and a set of associated resources. And we are going to see the difference between process and a program. Process means an instance of a program being executed in a process. Program means a program is a definite group of ordered operations which are to be performed. It is having some group of instructions. That is program. The process is an instance of a program. The process is a dynamic or active in nature, as it is an instance of executing a program and performing the specific action. Here the nature of the program is passive and it does nothing until it gets executed. A process has a shorter and limited lifespan because it gets terminated after the completion of the task. But a program has a longer lifespan because it is stored in a memory until it is not manually deleted. And in process, the resource equipment is much higher. In case of a process, it could need some processing memory and input output resources for a successful execution. But for a program, it just requires a memory for a storage. The program is a passive entity that has a set of codes and instructions. it is required to accomplish a task. A process, in another hand, we are seeing it is an active entity of a program that is started with the execution of a program. Thus, the process is started by the program once it is executed. Now we are going to see some computing environment. First, we are going to see mobile computing. We know that there are so many handheld smartphones and tablets are there. There are so many extra features are there compared to computer system, for example GPS and all. It allows new types of apps like augmented reality. It means it having more features compared to, see, nowadays we are using in mobile phones the maximum used and better performance operating systems are Apple iOS and Google Android. And next computing environment is distributed computing. We know that the collection of separate and possibly heterogeneous systems networked together. For example, in colleges, in computer lab, we are using this distributed computing only. Network is a communication path. TCP/IP, it is the most common network we are using. So many networks are there: local area network, wide area network, metropolitan area network, personal area network. A network operating system, it provides features between systems across network. It provides the communication scheme that allows the systems to exchange the messages. And this distributed computing means it is also same like the labs. The computers are connected in computer labs. There are collection of separate multiple systems that are connected together by using some network. Next computing environment we are going to see here, client server computing. Nowadays many systems that are act like a server that is responding to the some request generated by the client. We are the clients, users are the clients. Here the systems, many systems act as servers. They are providing some response to the clients. There are two systems are there: computer server system and file server system. What is a computer server system? Means it provides an interface to client to request services, that is database. And file server system, it provides interface for clients to store and retrieve the files. And see here this architecture, the server is connected with the multiple clients by using some network. Next one, peer to peer computing. Peer to peer means, that means end to end computing. It is also another model of distributing computer. It does not distinguish client and server. And before we saw that client server, that means one system act as a server, another system act as a client. But here all the systems are act as a client also, server also, and both also. Okay, that node must join P2P network. See here, all the clients here we mentioned in this diagram is client. It may be a server or maybe a both client and server. All the clients are interconnected. All the clients are here interconnected. So all the nodes are considered as a peers. Next we are going to see is cloud computing. We know that already what is a cloud means. It is a large storage area that is used for a internet connectivity. All the internet's connectivity throughout the world, all the internet's connectivity that is stored in a cloud storage area. It is an architecture for that. Thank you for giving this opportunity.